Hello, bonjour, and welcome to the Don't Waste Water podcast. I'm your host, Antoine Walter, and in today's episode, I'm delighted to welcome Jonathan Rhone as my guest. Jonathan is the president and CEO of Axine Water Technologies, a company specializing in the on-site treatment of the toughest organics in industrial wastewater. The world of industrial wastewater management is quite intricate. On the one hand, from an operator's perspective, wastewater treatment is a tax to be in business. But on the other hand, it's also a major risk. As soon as you exceed the relevant thresholds, you need to put your entire production tool on hold. And in the epic fight between bottom line improvement and risk mitigation, the latter often wins and water gets struck away. I know, the legend of Silicon Valley tells that you can take the world by storm with an idea, hard work, and a garage. But in the specific market we address today, you'll see that it needs more. It needs to turn the business equation on its head. I'll let Jonathan tell you all of that in a second. Still, you'll see that given the risk Axine successfully decided to assume on their very first reference years ago, you'll swiftly understand why he was recognized as industry icon in 2020. Now, before diving into today's topic, let me remind you that if you like what you hear, please share this episode with a couple of colleagues and friends. Thanks to all the ones I see doing it, it's heartwarming to see our water community grow week after week. So really do it, and I'll see you on the other side.
You're listening to Don't Waste Water, the podcast that helps water professionals to improve their wastewater treatment, optimize their operation costs, and keep up with the latest market trends. This podcast is brought to you by GF Piping Systems. As a leading supplier of piping systems made of plastics and metal, GF Piping Systems is the global expert for the safe and reliable transportation of water, chemicals, and gas. For more information, visit gfps.com.
Hi, Jonathan. Welcome to the show.
Thank you, Antoine. It's a pleasure to be here.
Well, the pleasure is all mine because we have a full plate of topics for today, which I'd like to dive in with you today. But I have traditions, and that involves starting with a postcard. And you're sending today a postcard from Vancouver. So what can you tell me about Vancouver, which I would ignore by now?
We're very lucky to live in Vancouver. Vancouver is a rainforest. We live in a rainforest. It's a very beautiful part of the world. And, it's interesting on the topic of environment that we're going to talk about today. It's been a little bit of an unusual year for us. We've had a pretty significant impact of climate change. We've had some of these things called atmospheric rivers that have given us record rainfalls. And in the summers, we have a huge forest here in British Columbia. So we seem to be alternating between wildfires in the summers and atmospheric rivers. So extreme swings in what we're dealing with. But we live on the ocean. It's a rainforest and it's very beautiful here and the people are lovely.
So the atmospheric rivers is really a topic which is coming back and back now because with these extreme events, more and more technologies and technology companies try to catch a bit of that water. But despite the hints, that's not what we will be discussing today, but more to that in a second. Before, I'd like to better know you. And when I was preparing for our discussion, I've seen different ways to introduce you. So I shall introduce you as an award-winning serial cleantech entrepreneur, that's an option, or a venture capital fund founder, which is also an option, aiming to transform the energy value chain. What is the best way to present you?
Well, thank you for that. I think of myself as somebody who is a serial entrepreneur in the cleantech area, but I think also I'm somebody who is passionate about the idea that cleantech innovations can fundamentally transform our world for the good.
What's your definition of cleantech, just that we have a common understanding?
Cleantech are technology-driven businesses that in general have an impact on improving the environment. Energy technologies, water technologies, energy efficiency, everything from carbon capture and storage to water technologies, transportation technologies. It's a pretty broad definition. You asked about Vancouver, and I'm very fortunate to live in a community where the cleantech sector is one of the fastest growing parts of our economy. And there are thousands and thousands of people who live here working every day to passionately improve the environment with new innovations in all aspects of our economy. So I would describe myself as being part of that community and somebody who's passionate about entrepreneurship in that area.
That goes also to one more level, because I've seen that you've been recognized as an industry icon. What's the story there?
Well, I think you'd have to ask the people who give the award out. But as I said, we've got a very cohesive cleantech ecosystem. There's an organization here that recognizes leadership in the industry. And I guess I've been at it for a while. Icon, I guess, is a very humbling sort of term. But, I've tried to help other companies in our ecosystem. I've tried to set an example of leadership, and I've been involved in a number of ventures. So I guess it's some way of recognizing the impact I've had on our community.
So talking of these ventures, the latest you're in is Axine Water Technologies. What would be your elevator pitch to Axine? And am I saying it right with Axine, or is it Axine?
Axine Water. Axine is a very exciting project. The whole reason we started Axine was a recognition that we are increasingly creating synthetic chemicals when we manufacture virtually any product you can think of, from pharmaceuticals to chemicals to automobiles to semiconductors. And the wastewater that's generated by manufacturing plants is increasingly complicated. It's got a lot of these very difficult to treat synthetic chemicals that don't easily break down and biodegrade in the environment. There's no obvious solution for how to treat those. And so therefore, many manufacturing plants are resigned to the fact of having to truck this water off site somewhere to be incinerated. And we think that that's a terrible idea. So we've created a solution that we can treat that water on site with a disruptive technology and do it as a service, so that our customers can focus on what they do and we can take care of these complicated wastewaters. So we treat industrial wastewater with these complex organic chemicals as a service under multiple year service contracts, generating recurring revenue in partnership with our customers. And it's a disruptive technology, disruptive business model, and we're making an impact in the markets we're at.
There's a lot to unpack in what you just explained, but we'll unpack it by sequence during the deep dive we will have together. I'd like to go back to the beginning of Axine. You said were you involved in the creation of the company?
I was. In fact, it's an interesting story because it's the story of, how many of these companies start. I had finished working in my previous company, and I was doing some work with a couple of cleantech venture capitalists and looking at their deal flow and helping them curate some of the opportunities that they were seeing. And I was introduced to the technical founder of Axine, and she was a PhD materials engineer. She had left a fuel cell company, and she had a vision to take the idea of electrochemistry, because fuel cells are all based on electrochemical processes, and apply it to wastewater. She had built some prototypes in her garage, and she was working away with different types of wastewater to try to figure out how to use electrochemical oxidation to break down and destroy these chemicals in a new way to solve what she believed was a big problem. And I was immediately taken by her passion and her ideas. I knew nothing about water or wastewater at the time. And, you might argue that I'm still learning a lot. It's a complicated area. But we formed a relationship in to explore how we could commercialize her technology and take it to market. And so that venture capital firm ended up investing in the company. We brought in new investors. And so she and I partnered to take the company forward. Fast forward to today, I think we're realizing her original vision of that she had for the company.
I don't want to fast forward. I want to understand that path, because it's something we've been discussing regularly on that microphone, how having a technology isn't sufficient in the water industry. You have to make a dent and you have to battle. I think Kobe Nagar from 374 Water on that microphone said it very right when he said that the full industry wants to be first to be second. So I'd like to understand how you go from that point where you're meeting your technical co-founder, which has this awesome technology, and You work together up to the point you get your first reference. What's the story of that first reference?
It's been a fascinating journey, I have to tell you. The way I would say it is this. Different than many other markets, and I'm from the energy industry, so I'm a relative newcomer to water. Water is a incredibly fragmented and challenging market, particularly wastewater. And the reason it is because every single application you look at has a completely different chemistry. It has different flow rates, it has different chemistry of the problem you're trying to treat, and then all the other background chemistry is different as well. So if you're creating a solution for addressing a particular application, you have to be able to address all these other related issues. And the other thing is that customers in wastewater, they're not interested in technology, so to speak. They want a solution. They want a complete solution that may incorporate your technology, but you have to be able to provide them with a complete solution. And the third thing that I've noticed is that wastewater is generally regulated. It's not a core competency of the manufacturing industry, so to speak, although they do have very competent people that are very knowledgeable about wastewater, but it's not the main reason why, a pharmaceutical plant exists or a semiconductor plant exists. And therefore, customers tend to be very risk averse. So taking all these things together, our journey was challenging. It really was. First of all, we had to make the technology work, and we really struggled. We struggled for several years. Treating toxic, complex organic molecules with electrochemical oxidation is a very difficult and technically challenging activity. And our vision was that if we were going to get into the market and be successful, we had to have a technology that was 10 times better than anything out there in the market. So we're competing against chemical oxidation, we're competing against incineration, and we had to be able to develop a technology that could be flexible and versatile to treat thousands of different types of chemicals. We had to be able to package it into a complete solution, and we had to be able to offer it to the industry in a format, in a business model that would minimize their adoption risk.
You mentioned that it had to be a solution and you had to have all these elements. Was it a given that you said, I have to have all of that? Or did you discover on the go that you needed to have all these bricks in order to be able to offer something which was compelling for those customers?
When we looked at the market, many technology companies will choose a pathway to the market where they set up distribution channels and they sell their technology to a larger company that might be able to integrate it within a larger solution. We decided to take a different approach where we would actually put the entire package together. So that was a fundamental decision point for us. We package our electrochemical oxidation technology with conventional pre-treatment, post-treatment. We deliver a full turnkey solution. And then we decided that we weren't going to sell the technology. We were going to sell it as a service. We go to customers and say, we can treat your water. We'll deliver a complete turnkey solution. We'll finance the cost of construction. We'll deliver it to your site and we'll operate it and we'll service it and we'll monitor it remotely. And we'll do it under a multi-year service contract. And here's the key point. We'll guarantee treatment performance. The whole point of that, Antoine, is we're trying to remove the technology risk and the friction of adoption. In our case, that business model has been really well received by the markets that we're currently in. And we're very excited about it because, there's sort of two parts to it. One is we're trying to address a market problem and accelerate adoption. And we're also trying to come up with a business model that works for investors. Investors love recurring revenue, and this revenue is very sticky. Once we establish a partnership with a big company and we can prove ourselves, then we can start replicating across their manufacturing network. But we can also address the problem of adoption. So those are some of the problems that we were trying to address.
I see why that is very appealing for the industrial player. I do see why when it's successful, it is also appealing to investors, but there's an element of risk. You're a young company. By the time you have your first references, you have your technology, which you said had some, let's say, childhood sicknesses to overcome, and you're going directly all in to saying you're offering everything as a solution, you finance it, and you take a treatment guarantee. How do you mitigate that risk?
It's a fundamental question. Here's how I'll come at that question. First of all, we had to have confidence in our core technology. That was the first principles. We had to develop an electrochemical oxidation technology and an electrochemical system that we had full confidence in. And that took several years to develop. And we had lots of failures. I would say the original concept of the technology we weren't able to make work. We were able to make it work perfectly for 30 hours and then 300 hours, but we needed 60,000 hours. We had lots and lots of failures in the development of the technology to the point where it was robust enough that we had the confidence to back it with our own money. And that's ongoing today. We have a technology that's sort of a generation 3. We're working on generation 4 and 5. We're adding machine learning and automation, new types of materials. It's working beautifully in the field, but we're not stopping with innovation. So that's the core of what we're doing. Secondly, we had to have a sophisticated enough and experienced enough team to be able to own the entire value chain. You think about it, we're not only developing the technology and we're continuing to innovate with the technology, we have to be able to take that technology and package it into complete turnkey systems. And then we have to be able to finance it. And we have to be able to deliver it to the field and set up a service operations network worldwide with a small company. So we have a whole value chain that we have to put together. And that requires a certain level of experience and knowledge, technical and business acumen to be able to do that. And it's not easy. But I do think that it has introduced a new type of standard in the market that customers don't need to understand how these very challenging wastewaters are treated with a high-tech solution. So if they're buying the technology, they need to know everything about it. And in our case, it's not just the hardware, the software that we use to acquire the data, which tells us how the system's performing. The two pieces go hand in hand. So it's very difficult to hand that off to a customer and let them take the risk. We are actually in the best position to take the technology risk. So if we're not comfortable doing it, why should a customer do it?
We've been teasing your technology now for the first minutes of this discussion. Let's go into it. What is this electrochemical technology which is at the core of your system?
Well, first of all, electrochemical treatment of wastewater has been around for a long time. And electrochemistry is used widely in a number of different applications. What we're doing is electrochemical oxidation. And there is a long history of development work of electrochemical oxidation of challenging complex organics. We are taking this to the next level. So what we do is we combine advanced materials in an anode-cathode configuration, and we apply electricity to those advanced materials. And that allows us to generate what's called a hydroxyl radical. One oxygen, one hydrogen, and you've heard of this before, one of the most reactive oxidants that can be produced. They're hard to make. And then we put these catalyst-coated electrodes into a reactor configuration. We turn on the electricity and we flow the water through the electrodes. The pollutants come in contact with these OH radicals, and the OH radicals grab onto the molecules and they tear apart the molecules. They break the bonds within the molecule, and they progressively oxidize those molecules back to their basic building blocks: hydrogen, oxygen, nitrogen, CO, CO2. And so these are benign gases that are then just released to the atmosphere. And people have been trying to do this for a long time. We have commercialized it, and now we're perfecting it. And now we're making it cheaper and more efficient by improving the application and the use of data and then the operation to make it more efficient and lower cost.
We'll go to the operation of the system, but on the technology itself, You mentioned how wastewater is a scattered field with many companies addressing many different types of water in many different environments. You have an interesting and different way to produce those hydroxyl radicals. Nevertheless, there are many companies which have many different approaches to generate the hydroxyl radicals. What makes you different in the middle of that almost red ocean of advanced oxidation?
Thanks for asking that question. There are many ways to make OH radicals in many different processes. Advanced oxidation processes are probably the most well-known, and there's many different combinations and configurations. So we don't use any oxidation chemicals in our process. What I would say is that in any application, you have to get to the point of saying, here's the treatment cost per unit volume. So cost per cubic meter, cost per gallon. Our sweet spot is in the industrial wastewater that has a concentrations of organics that are in the several thousands of milligrams per liter. And we're able to take those down to subparts per billion, or in the case of PFAS, parts per trillion. That's where we're hyper competitive. And the other area we're competitive is advanced oxidation can work extremely well with in some applications. We have not seen a molecule that we have not been able to completely mineralize and destroy. And that is a unique competitive advantage, and we can do it cheaper and more reliably with full performance guarantees that we provide over multiple years. And so I think we're bringing a very competitive solution to the market, both from a performance basis and from a cost basis. And treating oxidation of industrial water is complicated. Oftentimes, the oxidation process creates other mixed oxidants and byproducts, and our solution completely destroys all of those. So we have to be able to guarantee that. Without getting into the real nitty-gritty of it, those are a few of the areas where we see ourselves being very competitive.
There is one thing which really intrigued me about your technology, and I'm not sure I have understood it in my preparations to be really transparent with you. I've seen zero liquid discharge processes in the past. I've seen advanced oxidation processes in the past. I'm not sure I've ever met a zero solid discharge process. So that means that when you're going to this mineralization step, you're also going to gasification. So everything you have as an output is gas.
Correct.
Can you explain me that?
Yeah, there's no solid or liquid waste produced from our system. So these are solid state electrodes. The water is flowing through the electrodes and the oxidation happens. I mean, we've talked about the primary oxidation mechanism being OH radicals, but we also produce secondary oxidants. And we also transfer electrons directly from the surface of our electrodes to the chemistry of the pollutant. So there's multiple oxidation steps, but we do not produce any solid or liquid waste. Everything, the treatment process produces trace byproduct gases. And when I say trace byproduct gases, for any customer, we have to be able to quantify those, and they are extremely low concentrations, and they have to be, of course, validated and tested and so on. But they're all released directly to atmosphere.
I've seen two kinds of application in the references you had featured on your website. They're going, from my understanding, in two different directions. So I'd like to understand that. In some of your references, you have several pretreatments to concentrate the effluent, and then it goes to your proprietary technology, and you have this gasification or zero liquid and zero solid discharge. And in some other applications, you are a pre-treatment step, which enables to have a more effective and more reliable water reuse system. So in that case, there is a liquid discharge, but an ultra pure or quite clean liquid discharge. How is it that you're in those two extremes of the scope?
You've done your homework. Very good observation. Maybe it makes sense just to talk about the market application as well, because that's relevant to the question you asked. The primary market we're focused on initially has been the pharmaceutical market. What we've become really good at and expert at is treating active pharmaceutical ingredients in pharmaceutical wastewater. And so when I say active pharmaceutical ingredients, I mean everything from antibiotics to antiparasitics, hormones, steroids, cancer therapies. And these APIs, they get into the wastewater because during the manufacturing process, the plants have to rinse out the reactors that produce the APIs in the first place. And so they pick up trace amounts of these APIs and they end up in the wastewater stream. So we have a variety of different treatment applications for that problem. Number one, sometimes plants are able to segment the rinse water that comes off of the reactors that has the APIs in it. And it's usually fairly small volumes. And sometimes we can the most cost-effective way for us to solve that problem is just to treat that water neat. We don't need any pre-treatment or any post-treatment. We simply are able to put it through our electrochemical system and destroy the APIs down to below the predicted no effects concentration. In other cases, the API contaminated rinse water ends up going into the main wastewater stream of the plant. It's a much, much larger volume. And then we have to really consider what's the most cost-effective treatment solution. For example, if there's a lot of biodegradable organics in that water, it might make sense to put a membrane bioreactor as a pre-treatment step to destroy the biodegradable organics, leaving the APIs for Axine to treat. In other cases, we might have an MBR that destroys the biodegradable organics, but the APIs are very low concentration in a high volume stream. So then we will use an RO system, and the RO system will concentrate the APIs into the RO reject, and the RO permeate can be discharged or reused. And the reason we like to concentrate is because it reduces the cost of our solution, because we have a smaller stream with a higher concentration of APIs. So sometimes we'll use an MBR because it's much cheaper to treat biodegradable organics with a biological process. Sometimes we'll concentrate the APIs using an RO system. And sometimes we'll just treat the water neat, depending on what the application is. This really underscores something you and I talked about before. Every single application is different. So you have to be able to quickly evaluate what the composition and volume of the water is, what's the right pre-treatment process in order to provide a solution that's the most cost-effective for the customer.
So that means that for you, the first step in any kind of project is going to be to take a sample of the water or the API or the backwash or the stream you will have to treat, and to determine what's going to be the best strategy, and then come up with a treatment train.
You're pretty close. We've really, I think, honed and refined our approach to working with customers over the years. And I think this is a real source of competitive advantage for companies who do this. And we're always looking for ways to improve it. The first thing we do is we work with the customer. Most of them have some pretty good data about their water. They know what their volumes are. They generally know what the range of all the chemistry is in their water. So we typically do a paper exercise, and then we provide them with a preliminary proposal. We say, this is our treatment strategy based on what you've given us, based on the specification you've given us and what's in the water and what the goal is. And here's the unit processes, and here's what it would look like, and here's what it would cost over 5 years. And here's our service offering. We do that as a first step. Then they've got something that they can compare and they can use for decision making. They can use it for budgeting. They can use it for comparing to other alternatives. And then if they want to go to the next step, then we start getting samples of the water. We'll bring water to our lab, our product development center in Vancouver, or we'll do a field pilot, but we'll really dig into the chemistry and the process. And we'll work with them. Sometimes we find ways to make suggestions on how they can improve their water process. So we really partner with them to refine the strategy and the solution, to hone in on the scope, and then we work on a final proposal, both technical and commercial.
You mentioned the piloting. If you had to make a wild guess from your experience, how often can you skip the pilot?
In the early stages, we had to pilot just about every single time. And what we have done as we've developed a increasingly robust set of data on what the chemistry looks like, we're using advanced analytics, algorithms, and machine learning to be able to predict the performance of our technology. So we're using technology to define the system design, and then we're validating that with actual test results. And so the best way I can describe it to you, Antoine, is that our engineers, they don't really care whether it's an antibiotic or a hormone or steroid. What they're looking at is the molecular weight, how many carbons, how many rings are in that molecule, how many electrons are required in order to break all those bonds. And we're able to model that and predict that in an increasingly refined way. So that reduces our requirements to do field piloting and to be able to design based on data. And I think this is just another innovation that we're bringing to this area of wastewater.
To give you a bit of background for my question, piloting can be a technical requirement. Then you really have to prove something. But as you said, I would have expected, given the way you're set up, that you can have similar results by modeling and leveraging digital tools. But it's also a hurdle you have to overcome in terms of sales, because that is a point for the end user to get hold on your system and to gain confidence in your ability to do it. So most of the time, I'm extrapolating by saying most of the time. So that is my saying, it's not yours. Most of the time, those pilots are about reassuring the customer more than they are about proving something technical. But it's also a sunk cost, because as long as you're piloting, you're still in the sales process. You don't have a close contract. You're not in the active operation of the plants. So I guess that it has some financial consequences.
You're exactly right. It's a judgment call. On the one end, it provides a very, very valuable technical input on design standards and specifications. It also allows you to build those relationships at the plant level, provides confidence to the customer. So we still do piloting. I want to be clear about that. But piloting is expensive. It takes time. It's expensive for the customer, expensive for the supplier. It takes time, probably more than anything. I'm a tech entrepreneur, so I'm always looking for ways that we can, with reasonable risk, to reduce the cost of adoption. And, part of it depends on the relationship with the customer. We've taken a very strategic approach to market where we're focusing on some of the largest companies, where we can establish a beachhead under a master services contract and then start replicating across their manufacturing network. With those customers, where they already have systems in operation, they have a higher degree of confidence. We've already begun to win their confidence in our technology, not just our technology, but our ability to execute, which is equally as important. That's a little bit more advanced relationship that somebody's just getting to know us. So those are all factors that play into the to pilot or not to pilot, question.
I take a side note for myself, because that means you're much more persuasive than I am. I remember visiting some chemical customers and them telling me, whatever you've done with our sister companies or other subsidiaries doesn't count because we are special.
Sometimes that's the case. You're absolutely right. Yeah.
I've seen your recent reference in Puerto Rico. I don't know if the reference is recent, but the video is recent. So I've seen that one. And I have two questions. I'll take that one as an example. My first question is on the way you execute, because I was pretty blown away by your fact that you are 2 days on site, basically. So you do everything in off-site fabrication, you package it in containers, and you bring those containers on site. And between the moment that you enter the site and the moment when you leave with a system which is fully commissioned, there's 48 hours. How do you do that?
Oh, it's variable. It depends on the application. The goal is not, 48 hours or a week or 2 weeks. The goal is to be there as long as we need to be to support the installation, commissioning, and startup and performance testing. We also have engaged local technical support in every area that we operate. And we're getting better and better at defining the role of operations between the customer, what the customer and the operating team on the site will do to support the system, the local service technicians, our own team at our network operating system in Vancouver, and then our field services team that looks after the sites as well. So that whole system of service operations needs to function as a well-oiled machine. And, again, this is an area, if you're going to own the system and operate it and guarantee the performance, it has to be seamless from the customer. If the customer, as our VP engineering says, if you're thinking about the Axine system, we're not doing our jobs. That's a real passion for us to make that work very well. So it might say 48 hours, but that's not the goal.
Very clear. So my second question along the same line is, once it's commissioned, you have exactly what you just said. If you're thinking about the system, then there's a problem. So really you're delivering this thing that you're also operating remotely. I was curious about, first, how do you automate all of that? What's your concept of automation? And second, how much can the system work by itself?
Boy, there's a lot there. We could talk for a long time about system automation strategy, but I'll start by saying this. Our systems are designed to operate 24/7 without operator intervention. Things go wrong, pumps fail, joints fail, electrodes fail. That's normal industrial process equipment. It's very important to us that we have a locally engaged field services team that are able to respond within hours if required. All of our systems are wirelessly connected and stream data back to our network operating system. And it starts with the core electrochemical system. Those reactors are monitored 24/7. And when we do the testing and we do the commissioning, we establish what we call the heartbeat of the process. And it's a data heartbeat. And it's algorithms that give us the operating data signature of how those electrodes and how those electrochemical system is functioning in normal operation. And if that data heartbeat and that data signature goes outside of our error bars, we're notified immediately. And usually it's one of two things are happening. The wastewater is out of specification, or there's a problem with the electrodes. And electrodes are a consumable. They do need to be replaced periodically. They don't fail suddenly, but they will degrade over a period of time. And we always have backup electrodes on site. But we start with all of that data comes back into our network operating system, and it's all set up to provide us with alarms. And then that goes out to our field services crew. And we'll decide whether we have to dispatch the locally engaged people or one of our people have to get down to site.
I've made a bet for 2022. My bet was that we would see a wastewater treatment which would be running automatically. I do know process automation helps a lot and it's already quite automatic, but there's still a human which is taking care of all the elements. If my bet comes true, I would expect it to come from a system like yours, which is in the industrial world. Well, if you're taking guarantees at the end of the day, you're taking the risk. So you're also the one which is able to say, my machine is clever enough. You're saying you're leveraging machine learning, leveraging process modeling. So all of that speaks in favor of a plant that would be somewhere down the line really working by itself.
You have to be able to respond to mechanical failures, but the advances in automation, in sensor technology, the cost of sensor technology, and data analytics and machine learning is getting us a long way down the road. And I will say our product development and engineering team is half hardware and half software and data analytics. It is an incredibly important part of being able to deliver these complex systems. And, here's something else. We can't, as a company, neatly think about, we're going to just focus in the United States or Europe. Our customers, if they have a problem with a plant in South America or in Singapore, we have to be able to deliver a solution in where they need it. So that means that we have to be able to design, build, deliver, execute, service, and monitor wherever their facilities are worldwide as a small company. And one of the advantages of the pandemic was that it was the great leap forward in industrial automation. And it has taught us through necessity to be able to do this faster and better, and made it an urgent priority throughout the company. So it's a passion for us. And we're not 100% there, but we are a long way. And I think that that is a source of know-how and competitive advantage that will stand us in good stead for years going forward.
You mentioned you were a small company. How many people are working for Axine today?
We're just over 30, and we're adding people every month. We're in a pretty big growth phase.
And what's the driver to that growth?
I would say it's successful beachheads with multinationals that are earning confidence in the market and driving adoption, number one. Number two, we have some very exciting new applications that we're working on in the world of PFAS that we haven't talked a lot about, but we think that's going to be an exciting new market for us as well.
So if I try to recap all of that, that means that you have a differentiated technology, you have an approach with a full system as a service, you have a market which is booming, which is a good and a bad news because, this PFAS topic is here to stay. I mean, forever chemicals are by definition here to stay. In a nutshell, you have a business which is highly scalable. So does that mean you are on a path for hypergrowth? Is it some things you're seeing for the future vaccine, or is it like a buzzword which I should put back where it belongs as a buzzword? And
I think hypergrowth is one of those dangerous words that gets thrown around. Depends on how you define it.
I usually throw it once per podcast, so I'm one of these guys that throws around quite a lot.
I think the sustained momentum and growth is very exciting for Axine. These are industrial processes. All of our unit processes are modular and scalable, but they are custom designed, custom delivered systems depending on the water. And the exciting part about our revenue is that our revenue model and business model is that we're stacking recurring revenue on top of recurring revenue. So we've got a pretty exciting growth path from a revenue generation standpoint and a scale up standpoint. So if you think about hypergrowth in water, maybe it would be, but I think it's going to be steady, sustained growth. And we all have experience of this in industrial process technologies. We need to make every system work really, really well. We need really happy customers. That's the most important thing for us. And that's what's going to drive growth for us. So making sure that and we're not selling equipment, we're selling services. So we have very tight relationships with our plant customers and manufacturing customers. That's so important to us for sustained growth.
If you're looking in my crystal ball and I'll let you decide in 5 years, in 10 years, where will Axine be first, and what will tell you that you've succeeded?
Just stepping back for a moment, this whole area in industrial wastewater, in water in general, of these persistent, complex organic molecules, I think is a megatrend in industrial water. It's kind of below the surface, but I think the antibiotics, the concerns about AMR, antimicrobial resistance in the pharmaceutical industry has created kind of a tsunami of work at the manufacturing plant level to ensure that risk is taken care of. I think PFAS is another one. I think there are other areas within the chemical industry of these synthetic chemicals. So I think from a market fundamental standpoint, I just see increasing pressure on manufacturers across the board to treat water, and here's a novel idea. Let's take the clean water into our plants and let's put it back as clean as we got it. That's really, if you think about the other trends around ESG and how companies are thinking about do no harm and harm reduction with their manufacturing process, I see there's just a mega trend. So within that context, our goal at Axine is to be the world leader in providing solutions for manufacturing plants around the world, starting in the farm industry, moving into the chemical manufacturing industry and other sectors, and to continue innovating and improving our product roadmap is very, very robust from a hardware and software. We see opportunities for dramatic improvements in cost and performance, expanding our markets based on innovation. Those two pieces are, I think, what's going to drive us to being a world leader in this area.
Sounds like a path to glory and victory, but I wouldn't have expected anything different from an industry icon. So I think we're closing the loop somehow. I think that makes for a perfect conclusion for that deep dive. Unless I've missed an elephant in the room, I propose you to switch to the rapid fire questions.
It's time for the rapid fire questions.
So in that last section, I'll try to keep the question short, and your duty is to try to keep the answers short as well. And don't worry, I'm always the one which sidetracks the conversation. My first question would be, what is the most exciting project you've been working on and why?
I think with some of our multinational pharma companies, eliminating antibiotics and other APIs from getting into water is so exciting and high impact.
Can you name one thing that you've learned the hard way?
I can think of about 10 different things. Wastewater requires patience.
Do you have an example of that?
It goes back to the market is so fragmented. Every different industry market has different problems, a different market dynamic, and it requires patience and understanding to navigate and to find where the right beachhead application is. And it really requires a lot of listening from customers. So it requires a lot of patience.
Is there something that you're doing today in your job that you will not be doing in 10 years?
I think I will be less involved in day-to-day sales in 10 years.
How much does that represent in your daily job today?
Oh, well over 50%.
Okay. What is the trend to watch out for in the water sector?
I think it's all about the data. And I think that when I look at water, when we started Axine, I would have said that innovation in water was kind of 10 or 15 years behind the energy sector, which is my reference point. And I think that that's catching up. But I still think there is an enormous opportunity for the application of data in water. We're just getting started.
That's very interesting because we've been saying a lot on that microphone how we are usually lagging a bit behind by design for good and bad reasons in the water industry. And also that usually when you look at the energy sector, which is our cousin somehow, you're looking at the future of the water sector. So it's interesting to see that you've been doing that travel from the energy sector to the water sector. You experienced that, but you seeing it catching up is maybe a good sign for the water industry, maybe a bad sign for the energy sector, because if the laggard catches on you, it's not good for you.
You're right. You're right. I think the other thing that's going to happen is as we see the impact of changes in the climate, we're going to see a much more severe impact on water resources. We talk about the two being interrelated, climate and water. I think we're going to see that in very tangible and difficult terms in the next decade.
I do fear you're right. I would love you to be wrong on that, but you're absolutely right.
I would love to be wrong on that too, I tell you.
Well, that makes a smooth transition for my next question. If you were a world political leader, what would be your first action to influence the fate of the world's water challenges?
I think that my first action would be to put a price on water that represents the value that water has in our society. When I started in the energy industry, there was no price on carbon. A price on carbon is having a dramatic impact on the market, on the economics, and the adoption of solutions. And I think that it continues to be a gap today. Water is too cheap.
Yeah, I don't want to sidetrack you here because if I do, we are up for a totally new episode. But you're fully right. I couldn't agree more with you. It's been an awesome discussion on my end. I hope you didn't bother with my weird questions. would you have someone to recommend me that would be as awesome as you to have on that same microphone as soon as possible?
You know, I have been privileged to work with some of the most incredible people who understand water, I'm in my little corner of the water market. But I would encourage you to tap into some of the people in the pharmaceutical industry. There are some real leaders in that sector that are trying to address some really challenging problems, and they have some really interesting perspectives and experience.
I think that's an interesting recommendation because that's for sure a sector which must have some crazy water. I mean, what you said today is reassuring to me because I've met some of the industrials for which water was a cost to be in business. And I do believe that is something which is rapidly changing because this push towards reuse, towards different value streams around the water, make it appealing even for industrials. And also because companies like yours have this approach of turning it into a service, which changes the way you look at water. It's no longer this trouble kit, which is somewhere in your basement.
The reason why I think it would be interesting to talk to some of the leadership in that industry is maybe a little bit different. Water is becoming less of not just a compliance issue. It's becoming a strategic issue from an ESG standpoint. So if you're a big tech company and you need to hire the best and the brightest and you're selling products into public markets, it's important that the supply chain of making your products not be creating other problems for society. And it's important that you have a reputation of excellence in terms of managing your impact on the environment, because that's what young people care about today. You know, you think about attraction and retention of talent, the relationship between performance and commitments and ESG, and water becomes a really fundamental part of all of that equation. So it elevates it from compliance to strategic.
Thanks for the precision and absolutely interesting topic. So thanks for the recommendation as well. Jonathan, it's been a pleasure to have you on that microphone. If people want to follow up with you, where shall I redirect them the best?
They can go to our website, www.axinewater.com, and they can get a hold of us directly through the website.
Like always, all these links are in the episode description, so have a look there. It's been a pleasure, and I'm not saying if, I'm saying when you're that world leader in the solutions in that field, I'd be happy to have you back on that microphone to check on the next step of that fascinating path.
Thank you very much, Antoine.
Thanks.
Thanks for listening to Don't Waste Water. This podcast was brought to you by GF Piping Systems. Loved this episode? Head over to Apple Podcasts to subscribe, rate, and leave a review. See you next time.